Hello dear students, I hope you are doing well. I welcome you to the second part of S block elements. So in this part of the video, we'll start with atomic and ionic radii of group 1 elements. So we know the elements of group 1 are lithium, sodium, potassium, rubidium, cesium and francium. Now again we have to go back to the electronic configuration. Lithium atomic number is 3. So electronic configuration is helium 2s1. Sodium atomic number is 11. So it's neon 3s1. Potassium is 19. It's argon 4s1. Rubidium is 37. So it's krypton 5s1. Cesium is 55, so it's xenon 6s1. Francium is 87, so it's radon 7s1. Now if you look at the electronic configuration, the outermost cell 2, 3, 4, 5, 6, 7. That means the number of cells in lithium is 2, sodium is 3, potassium is 4, rubidium 5, cesium 6, francium 7. So as we go down, the number of cells increases. Number of cells increases. And we know if the number of cells increases, the size also increases. Now let us see how it affects the atomic and ionic radii. Radii is the distance from the nucleus to the outermost cell. Say if you take lithium, you have two cells, so this is the first cell, second cell. Second cell you have one electron, first cell you have two electrons. Nucleus will be here at the center. So the distance between the nucleus and the outermost cell, this distance is known as radius. Radius of lithium. So atomic radii is, or atomic radius is the distance from the nucleus to the outermost cell in an atom. Whereas ionic radii is the distance between the nucleus and the outermost cell in an ion. So first let us see the atomic radii of group 1 elements. So we know in lithium you have two cells, first cell, second cell. This is lithium. In case of sodium you have three cells, 1, 2, 3. First 2, 8, 1. Potassium will have four cells, 1, 2, 3 and 4. So for lithium, the atomic radii will be from the center to the outermost cell. That is second cell. Sodium from the center to the outermost cell. That is third cell. Potassium from the center to the outermost cell. That is fourth cell. Similarly for rubidium, it will be fifth cell. Cesium will be sixth. Francium will be seventh. Now, as we can see here, the length of the radius, it increases down the group. That means if you go from lithium to potassium or from lithium to francium, the atomic radii will increase. That means the atomic radii increases down the group due to increase in the number of electronic cells. Next, what about ionic radii? Let us see the ionic radii. So first of all, you have to know what is the ion, what is the type of ion formed by group 1 element. So lithium, atomic number is 3, so electronic configuration is helium 2s1. Sodium atomic number 11, so it's neon 3s1. Now in order to attain the nearest inert gas configuration, Lithium need to lose one electron. Sodium need to lose one electron. So all the elements of group 1, you'll see, in order to attain the nearest inert gas configuration, they need to lose one electron. So the ionic form of group 1 element, say if M represents group 1 element, where M can be lithium, sodium, potassium, rubidium, cesium and francium. So if this alkali matter has to attain the nearest inert gas configuration, need to lose one electron. And if it loses one electron, it will gain charge. What kind of charge? Positive charge. So the ionic form of group 1 element is unipositive. Now if you compare Li and Li positive, or say Na with Na positive, the atomic radii is longer than the ionic radii, simply due to difference in the number of electronic cells. Now in case of lithium, you have two cells. Nucleus at the center, two electron in the first cell, one electron in the outermost cell. Now if you remove one electron from the lithium, you have only two electrons. That means you have only one cell. So this is lithium positive, this is lithium. Now if you compare the radii, atomic radii is longer than ionic radii. Similarly, the atomic radii of sodium will be longer than the ionic radii of sodium. Same for the rest of the elements. Now, what about the ionic radii along the group? Lithium, Li positive, sodium, Na positive, potassium, K positive, rubidium, Rb positive, cesium, Cs positive, francium, Fr positive. Now, the ionic radii along the group follows the same pattern. That means, along the group, the ionic radii increases due to increasing the number of electronic cells. Lithium will have 1, sodium will have 2, potassium 3, rubidium 4, cesium 5, francium 6. So the number of electronic cells for these ions will increase down the group. That's the reason the ionic radii also increases down the group. Next is hydration enthalpy. Now, what is hydration enthalpy? Hydration means water. Enthalpy means energy. Now, let us take alkali metal ion. So let us take Li positive. Now this Li positive, because of its nuclear charge, high nuclear charge, what it will do, it will aid water molecule. That means it will form hydrated crystal. Now when it aids water molecule, when it forms hydrated crystal, it will give out energy. That energy is known as hydration enthalpy. Now as we go down from lithium to francium or cesium, lithium, sodium, potassium, rubidium, cesium and francium. As we go down, we know size increases, and if the size increases, nuclear charge decreases, and if the nuclear charge decreases, the tendency to attract the water molecule also decreases. So in that case, hydration enthalpy decreases. So we can say lithium will have the maximum hydration enthalpy, francium, or if you ignore francium, cesium will have the minimum hydration enthalpy. Next, we'll study the physical properties. So under physical properties, we'll first study the density. Now, the density of the alkali metal is low. However, it will increase down the group. That means as we go from lithium, sodium, potassium, rubidium, cesium, the density will increase. Exception, there is an exception here. Though it increases, the density, that means the potassium element, is lighter than sodium. That means the density of potassium is less than sodium. So the actual order is lithium, potassium, sodium, rubidium, and cesium. So this is the increasing order of the density. Next, melting point and boiling point. Now, the alkali metals, they have only one electron in the outermost shell. And because of only one electron, their tendency to form metallic bonding is very weak. That means they have very less tendency to form metallic bond, that is interatomic bond. And because of this weak metallic bonding, they have low melting point and boiling point. Next, let us study the chemical properties of alkali metals. So when it comes to chemical properties, we have to study the reaction of alkali metals with air, water, dihydrogen, and halogen. So we'll first start with reaction with air. Now, the alkali metals, they react differently with the air. Like if you see lithium, lithium will react with air, that is oxygen, to form oxide of the type Li2O. This is known as oxide. Whereas sodium, if it reacts with oxygen, it will preferably form peroxide of the form Na2O2. Whereas rest of the elements in the group, like potassium, rubidium, cesium, if they react with oxygen, they form superoxide of the form MO2. That means if potassium reacts with oxygen, it will form KO2. If rubidium reacts with oxygen, forms RbO2. It's known as superoxide. Next, let us see the reaction of alkali metals with water. So if M is an alkali metal, if it reacts with water, it forms an alkaline solution, that is hydroxide form, OH, plus it will form hydrogen gas, that is H2. So if you have to balance it, multiply here by 2, 2, and 2. Say for example, if sodium reacts with water, it will form sodium hydroxide and hydrogen gas. If potassium reacts with water, forms potassium hydroxide and hydrogen gas. Similarly, the rest of the elements will react with water to form hydroxide and hydrogen gas. Next, let us see the reaction of alkali metals with dihydrogen. So alkali metals, if they react with dihydrogen, that is H2, it will form hydride. Now what is hydride? We know hydrogen atom, if it gains electron, it forms H negative. If it loses electron, forms H positive. Now in a compound where hydrogen is used as H negative is known as hydride. That means in alkali metal reaction with dihydrogen, alkali metal will be electropositive and the hydrogen will be electronegative. That means the hydrogen will be used in the form H negative. So that's why it's known as metal hydride. Say for example, if lithium or say sodium, if it reacts with dihydrogen, it forms NaH, that is sodium hydride. If potassium reacts with dihydrogen, it forms potassium hydride, that is KH. Next, let us see the reaction of alkali metals with halogens. First of all, what is meant by halogen? Halogens are the group 17 elements like fluorine, chlorine, bromine, iodine. These elements together, they are known as halogen. Now, how do they react with alkali metal? Halogens, if they react with alkali metal, they form metal halide. Now remember, in a reaction, the halogen is written in the molecular form. That is, Cl will be written as Cl2, Br will be written as Br2, I will be written as I2. So let us take an example. If sodium reacts with Cl2, that is chlorine, it will form sodium chloride. If potassium reacts with chlorine, forms potassium chloride. If potassium reacts with bromine, forms potassium bromide. Next, anomalous behavior of lithium. Now, this anomalous behavior, what does it mean? It means lithium, it behaves differently from the rest of the elements like sodium, potassium, rubidium, cesium, francium. This is due to the small size of lithium element. Lithium has got a very small size compared to the rest of the elements. So because of that, lithium, it behaves differently. Like most of them are highly reactive, but you'll find lithium reactivity is low. Most of them, they have low hydration enthalpy, but lithium you'll find that hydration enthalpy is very high. Most of these you'll find they will prefer ionic compound, but lithium prefers covalent compound. Rest of them, they are easily soluble in water, but lithium is not easily soluble in water. So these are the behaviors which lithium has different from the rest of the elements. So in the next video, we'll start with group 2 elements. Thank you.